What's the latest on the Fermi paradox?
The Fermi paradox.
Is there emergent thinking on this?
Well,
just let me set the stage here. Enrico Fermi famously declared, "Where are they?" Given the size of the galaxy and the fact that the galaxy has been around a long time, that there's plenty of time for a civilization to rise up, send out a mission to multiple planets, pitch tent, use local resources to build more rockets and go to 2 planets, 4, 8, 16. You can do this in hundreds of millions of years easily.
Right.
Without even warp drives or anything, right?
1/10 the velocity of light.
1/10 the speed of light. Right. Very modest for any modern civilization.
Yes.
Still not us. We're not in that category yet. And if that's the case, the galaxy could and should be teeming with alien civilizations. So where are they? What's the latest?
That's what he said. Where are they?
Yes.
Okay. I wrote a paper on this in 1993. It was called Implications of the Copernican Principle for Our Future Prospects.
Okay.
And astronomers love the Copernican Principle. It says your location is not likely to be special. We live around an ordinary star in an ordinary galaxy in an ordinary supercluster. We're used to this idea. It's been used by Huygens to calculate the distance to Sirius, arguing that why should the sun be the brightest thing in the universe? These other things are stars, and they're just like the sun. And so what if they were, knowing how dim it was, he got the distance to Sirius accurate to a factor of 20, which was extraordinary.
I heard long ago, and I checked it out, and I think it's true, that all mammals live for about the same number of heartbeats, except for humans, who live 2 or 3 times that. Except if you go back far enough in time when we were just living in caves, we were right with all the rest of the mammals. Yeah. So first, is that true? Second, there are animals, not mammals, that live much longer than we do. I'm thinking of the Galapagos tortoise, for example.
Yeah.
So do you guys study other animals to get insight?
There is a whole field devoted to looking at lifespan of different species. And you are right that, at least among mammals, Jeffrey West, who's written a book called Scale, shows that the number of heartbeats is roughly the same. That has to do with the fact that smaller animals have a higher metabolic rate. Right. They have a faster metabolism, and they almost need to because their surface to volume ratio is larger. They dissipate heat more.
We did a whole explainer on surface to volume ratios.
And so they need to maintain a higher metabolic rate. That's one of the reasons.
Well, that's only one of the reasons why they have higher heart rate. That's not a reason why they should die sooner. I didn't know he did this calculation. Brilliant step to make.
Yes.
So Christian Huygens,
yes,
a Dutch polymath,
right?
Yes, and I own one of his books, a charming book, Celestial Worlds Discovered. We just speculates on what life would be like on all the planets. So he looked at the sky and said, maybe if the sun is ordinary, so are these other stars. Is that right?
Right.
So if the brightest star in the night sky, Sirius, is just like the sun, how far away would it have to be as dim as we see it,
right,
given how bright the sun is in front of us today? To even have that thought is brilliant.
That thought is brilliant. Yes.
Okay.
But the most spectacular success of this was when Hubble discovered that all the galaxies were fleeing from us.
Edwin Hubble, the man, not the telescope.
Not the they named it after him.
Yes.
They're all fleeing from us, and the further away, the faster. It's a homogeneous expansion away from us. We did not go we're not going to say we're at the center anymore. We're not going to fall for that again after Copernicus.
The why we should die sooner has an evolutionary explanation, and that is evolution doesn't care how long you live. It only cares about fitness. Fitness in the biological sense is the likelihood that you're going to be able to successfully pass on your genes.
And people always misinterpret that as being physically fit or stronger or whatever.
Survival of the fittest, as in, I'm in great shape.
Yeah, Darwin should have found a different word.
He should, yeah.
So evolution cares about fitness. Now, at the same time, for most of our history, and certainly the history of all other species, resources are limiting. And so you have to select. Do you put more of your resources into maintenance and repair of the individual animal, or do you put it into growth and reproduction? There's always a balance if you have limited energy. So in the case of a mouse, which lives about 2 years in the wild, there's no sense in having a mouse live for 40 years because long before that, it's going to be eaten.
Yep.
Exactly. You beat me to it. Or it'll die of starvation or drought or something.
We're going to say, why would we be in the one special galaxy for which all the others are fleeing? No. If it looks that way to us, it must look that way to everyone. You live on any galaxy, you've got to think that you're the center and you've got to see it all of them expanding away from you. Then you get a homogeneous expansion, like pennies on an expanding balloon. Each penny sees all the others moving away from it, and it thinks it's at the center. And then you get the homogeneous models of general relativity, Big Bang models. And Gamow and his students, Herman and Alford, then calculated that there would be hot in the early universe and that we could see the microwave background radiation left over from that today.
All of that based on this assumption.
That you're not special. And you get all of that. And then this prediction was that there'd be microwave background radiation left over from the Big Bang of 5 degrees. And I worked with Penzias and Wilson in graduate school, did a project with them. I observed on the telescope. They got the Nobel Prize
for that first measurement.
They discovered the microwave background, 2.7 degrees. This is like predicting that a flying saucer 50 feet across is going to land on the White House lawn and one 27 feet across actually shows up. This is the most extraordinary prediction in astronomy, and it shows how powerful the Copernican principle is.
And so in the case of a mouse, evolution has favored selection of a species that grows very quickly and reproduces prolifically. That's a mouse. If you get to a large animal like a bowhead whale, let's take an even bigger than an elephant, they can live for 200-300 years, and they have a very relatively slow metabolism.
Wow.
An even slower metabolism is not a mammal, but it's still a vertebrate called the Greenland shark, 700 years.
What?
Listen to that, yeah.
A vertebrate living for 700 years, very slow metabolism.
Wait. How do you know that? We didn't even have marine biology 700 years ago. So how do you...
They can do things like carbon dating and then look
they
at the
cut one
tissues
open, it was
and
with
so on,
700 rings inside. I mean, you've got on the scale.
I'm just
No. So you've got the mayfly lives a day,
Mayfly lives a day,
right?
exactly.
And then between that, you've gone from there to a Greenland shark. And your Galapagos
and there are
tortoise
actually
is in
other
there.
animals that are thought not to even age biologically.
What's the immortal
like
jellyfish?
The hydra and the immortal jellyfish. These things
Wait,
have...
there's an actual animal called the Hydra?
Yes, that's right.
Awesome.
Not just in
G.I. Joe?
No.
No, Marvel.
No. In Greek
mythology.
legend. In
Yeah.
mythology.
Oh, you mean the real Hydra?
Yes.
Oh, yeah.
This is a freshwater small animal. And they're full of stem cells, so they're constantly regenerating themselves. But if you followed an individual, it would also age only very slowly. It's just in the wild, it dies for other reasons before actually aging.
Mm-hmm.
So there's a whole range. Now,
So humans might be the only species that dies of natural causes in the world. I mean, if you want to think about it that way.
Possibly,
So my paper, 1993, which people should remember, here's its answer to the Fermi question. It's real simple.
Just to be clear, you're purely invoking the Copernican principle to arrive at this conclusion.
Yes.
Not fundamentally differently from the way Gamow invoked the Copernican principle layered onto the data available to him at the time. Okay.
And Huygens.
Yes.
Right. So here's the answer from the Copernican principle, and it's very simple. A significant fraction of all the extraterrestrial and intelligent observers must still be sitting on their home planet, or else you'd be special. If there's a giant galactic empire out there that we don't know about, they've conquered the whole galaxy, and they're just hiding, They don't want the likes of us to know. We're in a little experiment for them,
That would make us special.
Because if you're an intelligent observer, you should be one of the people in the big one.
Okay.
In fact, you can say if you're a person on the world today, you should likely be born in one of the countries that's above the median. Half the countries in the world had, when I looked at this, a population less than 7 million. You're born in America. That's one of the 3 big countries. You don't have to be in the biggest country. I had a mentioned this to Stephen Hawking once. He said, according to this principle, I should be from China. I said, no, that's a minority of the people on the earth. You should be above the median, which is 97% of the people living on the earth live in countries above the median. Little bitty countries with small populations, you're not likely to be from there. You're likely to be from a random place.
And what did he then say?
He smiled at me. That's the way Stephen Hawking was.
I think that may be true. In fact, there's a book written by Stephen Ostad called Methuselah's Zoo, where he talks about all these animals. In this book, he points out...
Methuselah Zoo.
In Methuselah's Zoo, he points out how all these species have such different lifespans. And it's because of this evolutionary selection. But it's actually worse than that. The fact is, evolution will select for things that help you early in life, even if they cause a problem later in life. So many of the things that cause aging are related to growth, for example, or to cancer prevention, prevention or senescent cell creation. These things all help us early in life, and they're a problem later in life. But evolution doesn't care what happens to you when later in life.
When you're not making babies.
Right.
Yeah.
Exactly.
Yeah, because that's the whole deal.
So what helps us survive in infancy and then go on to reproduction is the key component of our decline and demise.
Not always, not
Okay.
everything, but there are things that happen to us early in life that are selected for early in life that cause aging.
So the real deal is just keep having babies your entire life, and then you'll never age. However, you will eventually kill yourself because of these kids.
So we're an outlier.
Time I had dinner with him, and I asked him a question, and it takes time. I mean, plus he's eating, but he has to spit it out because his throat doesn't work, but he tastes the food, and he's typing out replies with his eyes, right. on his device.
Right.
And I said, how come Isaac Newton didn't figure out how to stabilize the solar system, and he needed Laplace to figure out perturbation theory to show that every time a planet goes around, it's not tugged out of its orbit by Jupiter? Because Newton was upset about it. He didn't know. He didn't have an answer.
Right.
In fact, he credited God for coming in and fixing things every now and then. So I posed that question to him. And then 15 minutes later, out comes the answer. It's, you can't think of everything.
I know. That's great.
That was a dewdrop of wisdom. And then he went on to say, Einstein didn't think of black holes.
Right.
You can't think of everything.
That's right.
People got Nobel Prizes off of black holes
Right.
that he didn't predict off of his own theory.
He predicted gravity waves.
That got Nobel Prizes too.
That's right.
Crumbs off his plate.
He didn't even get it for general relativity.
I know. That's great. That's great.